Okay, good morning everyone. So it's nice to see that the room is filled in once again. And hello to everyone also who is connected online following the event. I'm Roberto Caney, so welcome to day 2 of LaserEMobility Workshop 2022. Once again, thanks to everyone who attended the workshop, who contributed to the organization, our sponsors. So I think this has become a nice event so far. Today we have a lot of things to discuss. As the workshop proposes, we will speak to the end users today. We will speak to the system manufacturers. And the idea is that we will sit down by the end of the workshop to have a roundtable discussion. This morning we will start with some very interesting companies, Italian excellence in automotive, motorsports and so on. And in 2022 it is very exciting to speak about electrical vehicles that have come to this level also in faster vehicles, motorsport vehicles and so on. But the idea is that since I have your attention, I would like to say a few words about LaserEMobility. So I will take only 5 minutes of your time to show you some slides and perhaps speak about what we can do together, because I believe that it is a very exciting opportunity to start to expand our network. So once again, I'm Aliyo Kandemir, Associate Professor in Mechanical Engineering from Politecnico di Milano. So just a few words about what we have been observing. So a lot of us come from different parts of the puzzle. The common thing that we chose today is mobility with lasers. But the point is that there are a lot of things that we have been seeing. There are a lot of things that we saw yesterday and we will speak about today. The point is that lasers, optics and sensors are established tools. So we're aware of the fact that they're also costing less, they're becoming commodities. There are a lot of solutions out there. We have been seeing a lot of these solutions also in our workshop. The market is increasing. We have only a few numbers. Last year's number hasn't come out, at least. I like to refer to Industrial Laser Solutions, which is a nice sectoral magazine. So the market is expansive. Then the question is, the market demand is high. Somehow the lasers are struggling to be inserted in the market. So the questions are, why aren't we able to spread the use of lasers much more than how they're being used today? So what is the missing point? And one of the things that we keep coming up to is that perhaps we need to define the process product metrics. So we have been seeing good results, but can we define what means good? Now, let's not go immediately to standardization, but how do we define the quality of our products? How do we qualify them? Because we need to see these things in order to go for the next leap. Other types of energy sources, other types of batteries and storage systems and so on. So the idea is, we have been seeing these models, right? Some nice charts about who does what. So we have laser source and component producers, end users, system integrators. We have been seeing that we usually speak about a linear way of things, but apparently in order to move forward, at least in this part of the world, that we see that we have about a few years left to keep up with the pace, we need to speak together, we need to discuss things together in order to make electrical vehicle production a reality. In Europe and also the energy storage system. So LaserEMobility has the aim, the humble aim, to sit in front of all of these players, be the one that creates the network, facilitates the communication so that we can have the right way of collaborating. So LaserEMobility is the name of our workshop, but I would like to just remind us that LaserEMobility is a network of universities and companies. We call this a section under ITEM, that is the Italian Association of Manufacturing. So it was founded by 3 academic and 3 industrial partners. I'm grateful to my colleagues from Bologna, from Munich, and we have from the industry, IMA Automation Atop, MANS and Relays, and they represent also some significant companies in the e-mobility sector. So the idea is this: we're a group of universities and companies, and we would like to expand, because I've been speaking to some of you here present, and the question was, can we be a part of it, or how did this thing start, and what's happening? So actually I'm speaking to you as the scientific responsible of LaserEMobility, and the idea would be to start collaborating and networking. And you have heard of these things probably so many times. The question is, what do we do, and what is the benefit, or what is the things that we can do within this network? So some very simple proposals and some very open questions that we can discuss throughout the workshop, afterwards, and so on. So I have been also speaking to people, and one of the questions was regarding the fact that we wanted to share knowledge, and we need data. We need to show people how things work. So one proposal comes as an atlas of laser mobility applications from the emerging ones: application, solution, quality metrics, measurement outputs. Shall we do this? Do we want to contribute to this? So a series of applications given in simple documents so that we can share it with the world. So the next idea is a bit more provocative, maybe. Let's do academic work, PhD for the emerging laser mobility applications. Here we are, academy, coming from 2 European countries which have a lot to say in this area. We already have companies around us. Would you like to sit down with us, propose a PhD, so that we can develop solutions, so that we can gather data, so that we can also systematically analyze what we need for this sector? So these are 2 ideas, and I'm actually closing this very introductory speech as call for partners. Who wants to join in? Would you like to be a part of LaserEMobility with these initial ideas? We have a lot of things to do as well. Our aims encompass a lot of activities in terms of divulgation and know-how sharing. But let's say, as we want to expand, these are some 2 basic ideas that you here, but also you online, could contribute to. So I thank you very much for this short introduction. You can contact, of course, me, Professor Fortunato, and my colleague, Mr. Kriegler, regarding all of the aspects that you would like to speak about, but this is an open proposal. Okay, so thank you once again for your time. And let's start with the end users. So I think it's a very, very interesting morning that we have today. We have the Italian excellence in automotive and motorsport. So we will start with Mr. Roberto Caney from Ducati. And I personally thank for the organization for everyone, because Mr. Caney is actually testing right at this moment. An excellent thing to be a part of, also remotely. So thank you very much, Mr. Caney. I hope that the vehicle that is very much connected to this workshop is doing fine, so that we can also hear about the results. So the virtual podium is yours.
Thank you so much. I hope you can hear me. Yes, I'm sorry, but I am here in Mugello at the racetrack, the famous racetrack of Mugello, because today we are testing our electric motorcycle, so I had to come here. First of all, thank you very much for calling me to this workshop, and congratulations to the organization, that is fantastic. And let me introduce myself. I'm Roberto Caney. I'm the e-mobility director for Ducati. That means that Ducati is starting with new endeavors in the electrification, and I'm in charge of this new adventure. Next slide, please. Um, I would like just to spend very few words about Ducati. What is Ducati for the, I think, few people who don't know what is Ducati. Next slide. Ducati is a company located in Italy, especially in Bologna, in Borgo Panigale, where is the R in particular is located the R&D department and also all the research for electrification too. We have a couple of plants, one in Thailand and one assembly line in Brazil. Ducati is also spread around the world with subsidiaries and connected with the local suppliers. Next slide. I would not spend so much for Ducati except for the results of the last year. We recorded an incredible year because we sold almost 60,000 motorcycle. And it's a record for Ducati. It's the best year we had in all our history. And we recovered also what we lost during the past year, especially due to COVID pandemic that everyone knows. I wanted to underline this because even if electrification, and we will see numbers in a while, is growing, the big displacement thermal motors have still a very interesting market. That's one of the reasons, but we will speak about that, why Ducati is so shy for electrification. Next slide, please. Last year was fantastic, as I mentioned, not only for the results on the market of thermal motors, but also because we decided, and we told to the world that we will enter the MotoE Championship. MotoE Championship now is organized, is still and it will be organized by Dorna, but now there is another provider of motorcycle, but from next year we will provide the motorcycle to all the teams that will run in this championship. The idea in Ducati was to join this championship in order to put, let me say, the first foot into electrification and somehow exploit this championship to start to gather some knowledge and create a department inside Ducati that wasn't present in Ducati before. Next slide, please. I would like to spend a few words about MotoE. What is this motorcycle? Next, please. Okay, this is the motorcycle that tested last year in Misano. It's a racing motorcycle. We started with an application that is, let me say, somehow in our DNA. Because especially I come from Ducati Corse, but Ducati is, let me say, there is a lot of knowledge for very high-end and performant motorcycles. So the idea was to start with something that from, let me say, vehicle point of view is known inside the Ducati. So what you see here is a motorcycle that has some similitude with the MotoGP motorcycle, is intended to be very light, fast, a proper racing motorcycle with all the parts designed internally, made by our suppliers, but especially on some parts like electronics, we are using what we developed in years for the racing. The idea is to provide all the teams with this motorcycle for 4 years, starting from 2023, next year. Next slide, please. Here I took some picture of the motorcycle that we tested in Misano last year, and also we had a couple of tests beginning of this year, and now we are here at the racetrack of Mugello for a test with our test rider Michele Pirro. Next slide that you will see. Okay, this is another picture. Next slide. Okay, and here is Michele Pirro in action that is testing our motorcycle. I have to say that he is an experienced rider, and he was so happy to ride this motorcycle. He stopped during a lap, shouting at us, "It's incredible, it's fantastic, it's so fun." So this is something we have to take in mind for next products that we will provide to the market. Next slide. Okay, very quickly also on the MotoE itself, how it is made. As I mentioned, it's a racing motorcycle. It's made of especially aluminum machined part or casted part, but with the idea to reduce as much as possible the weight, because this is also an important issue, and especially for electric motorcycle. All battery pack, seat support, and fairings are made of carbon fiber. Next slide. Okay, this is the let me say most interesting point probably for this workshop, because we struggle not only for the weight of the motorcycle itself with carbon fiber or other lightweight parts, but we had to concentrate also on the performance of the motorcycle. And that means also that we had to gather the best efficiency, to get the best efficiency on both aspects, resistance and cooling of the battery pack. Because, you know, here I'm showing the electric equivalent model of a cell. But there is not only the internal resistance of the cell that, of course, we have to reduce as much as possible, choosing the best cell, but there are other aspects to be kept in mind that are especially the resistance of the connection. And here, laser can be interesting. But not only for the electric connection that has to be the best possible. Also, the thermal resistance is another point very important for performance vehicles. So we have to cool the cells as much as we can, of course, because when we request a lot of current to the battery pack, they, of course, they are getting hot. And also, in my opinion, also laser welding can be an interesting solution to help the heat sink from the poles of the battery. Next, please. Okay. Having said that, let me spend very few words, but especially reason with you about electrification for Ducati, I mean, for high-end motorcycle. Next slide. Okay, Ducati is involved in electrification and invests also in research, and has very tight collaboration with the University of Bologna. This moto student is only one aspect, but it's an important aspect of this collaboration, and we are quite proud of the job made by the student. They could achieve the first place during the last moto student competition. I have to congratulate them. And because they are working very, very well, and they are source of very interesting ideas. And we like, personally, I like a lot of the collaboration we have with them. Next slide. But let's take a look at what happens on the market. Here you can see on the right side of the screen the result reported by ASEM, the Manufacturer Association, of the registration of motorcycle of last year compared to the year before. We see an interesting increase of around 7-8% in Europe of overall motorcycles sold in European countries, and with an interesting increase of around 28% in Europe of electric vehicles. But despite this, the market of electric vehicles, and here ASEM reports also the mopeds, so big displacement, equivalent displacement motorcycle, is not so high. So let me say, this is one of the reasons why we are so shy and we still haven't entered this market. But there are other reasons that are, of course, cost of the parts that make an electric motorcycle, and technical barriers. Technical barriers, as I mentioned, is in particular the weight of the motorcycle. Next slide, please. Here you can understand what I mean. If we compare 10 kilogram of if we compare the energy of the gasoline, I took here an example of 10 kilogram that could be an equivalent of 13-14 liters tank. You have to add other 15,000 150 kilograms of weight to get exactly the same energy. That means that if you compare a motorcycle, a racing motorcycle, powered by an endothermic motor and electric one, there is no way to get in this moment, with the technology that we have now, of course, there is no way to get the same performance in terms of weight. For cars, maybe it's a little bit different because they have 4 wheels, but for a 2-wheeler vehicle, it's the weight is very, very important. It's the most important, let me say, parameter of a 2-wheels vehicle. Next slide. But Ducati has a vision, and the vision is to be the most desirable brand, I read here, for power 2-wheeler products. And I added also to this statement from Ducati, whether it's high endothermic motor, thermal motor, or electric vehicle. And this is our goal. So next slide, please. The idea is to, this is also my task, to exploit new technologies, new ideas, new chemistries, new technologies also in welding, power, heat sinking, and so on. And why not taking in account that new regulation, new mindset are going through electrification, to start to think and find something very new that is in the DNA of Ducati to provide a very interesting electric vehicle. So stay tuned. Next slide, please, and thank you so much.
Thank you very much, Roberto. And
Thank you.
I don't know if you can stay with us for a minute to see if we have any questions. I'm turning
Sure.
to the audience if we have any questions towards Ducati's electrification challenges that we have seen so far. If not, apparently we have a question. Roberto, you can't see, but we have people.
Yeah. I see some of them.
So thank you for the very interesting speech. I just wanted to ask if beyond laser welding, you have other laser-based processes that you're currently employing for the manufacturing of your vehicles, be it either endothermic or electric vehicles. Thank you.
You're welcome. It's not easy to me to answer you. I guess yes, not in particular for this racing motorcycle, but I heard from colleagues that we are using, for example, laser-cutted parts for special parts, but I cannot be so precise, I'm sorry.
Maybe I can ask a question very quickly, Robert, because you mentioned something that is very nice, that you're very much connected to the university in terms of racing. So racing is very demanding for manufacturing. You need to get things right first time, or maybe the second time, because
Yeah.
because the reliability is for each race, for each chance. You have one chance to get it right, or you have very little time. So, and there are a lot of new manufacturing processes, lasers, and how do you see the differences with the electrical vehicle in terms of reaching the race, reaching the target, whether it is with these university competitions, but also the competition vehicles that you're making?
Yeah. The concept is exactly the same. As you mentioned, racing is important not only for the performance, but also for the reliability. So I agree with you. The electric vehicle must be as much as reliable as the as a MotoGP, let me say. And but it's not only a matter of racing. Let me add, it's also for the production motorcycle. The race in certain terms is limited. You know, we have only one chance, as you said. There is the race, and we have to run during the race. We don't have to stop the motorcycle. But it's not so different for a motorcycle that have to run miles and miles on a road. So it's more important to be reliable. Let me add also that there is another topic that is important for electric, that is safety. We are working a lot on this issue because, you know, especially for electric vehicles powered by performant motors, that means also high voltages, and lithium-ion cells that everybody knows that must be treated somehow the right way. The safety is also very important. So that is a point where I think we worked a lot, and we have to work a lot also on road bikes.
Thank you very much, Roberto. I think we're okay. Thank you very much for dedicating your time, and I know that you have some very interesting things to attend. We have your colleague, Mr. Simone Di Piazza, here with us. So I guess the attendees who might want to have a chat, maybe they can have that opportunity over here. Thank you very much for your time. Enjoy the track. Sì.
Yeah, thank you so much. Enjoy your workshop too.
Okay, so moving on to four wheels, let's say. I have the privilege to announce the next speaker, so from another Italian excellence that we know very well. So Mr. Paolo Feverzani, hybrid components development from Ferrari, will speak to us about the electrification, how it's moving on with the Ferrari. So the floor is yours. Thank you very much.
Hello everybody, I'm Paolo Faverzani and I'm responsible for the mechanical development of hybrid component in Ferrari. Now we see a few slides to describe the experience in electrification in mobility in Ferrari, and we focus on the laser application inside this component. First of all, we see some of the cars that use e-components, so are used for e-mobility in Ferrari. The first one is La Ferrari, start in 2013. We see the powertrain of these cars and all the components that are typically used in e-powertrain. We have the battery, and in this case is located in the front part of the car. We see the two electric machines, and the name P0 and P3 are identified the type of installation inside the powertrain. So P0 electric motor is typically a belt generator, high voltage generator, that is connected to the thermal engine. And the P3 electric motor is directly and rigid connected to the gearbox. We see on the top the power electronics where it is integrated the DC-DC converter. 2 years ago, 2019, we can, everybody know, we present a SF90 Stradale, and it's completely different than the previous one. It is the first four-wheel drive with a front e-axle. The two electric machines that are on the axle are named P4. On the front side of the car, we see the DC-DC converter, the power electronics from the e-axle, so it is a completely full assembly component. In the rear part of the seat, there is the high voltage battery. And between the engine and the gearbox, there is the P2 motor. At the end of the car, we see the power electronics for this electric motor and the onboard charger, because this is a plug-in vehicle. Last year, the last hybrid Ferrari we present is the 296 GTB. Is not a four-wheel drive, so we have only one electric machine that is located between the engine and the gearbox. And the high voltage batteries, it is always near the seat. And also this car is plug-in, so we see on the rear part of the car the onboard charger and the DC-DC converter, always the power electronics for the electric machine. To develop all the component, all the electric machine, electric motor inside this type of cars, Ferrari developed, and with the help of Università di Bologna, the technology for the welding of the hairpin with high reliability of this process. We start from some, as we can see, start from the geometry of the hairpin and to give the right shape, find out the right laser welding process, in terms of parameter, in terms of type of laser, to have the correct welding process, but also the right time cycle on the production. Now I give you an example of what have been developed with the university. Try different working pattern during the welding of the hairpin. For example, the wobbling with a single shift, so only one shift with the wobbling. On the other side, we try also the linear rectangular pattern or the circular one. For each of these type of welding have been performed some mechanical characterization to identify, for example, how long is damaged the hairpin, the enamel, how much have been damaged from the high temperature reached during the welding, and also the mechanical properties have been impacted from the heat treatment at the end of the copper. We can see the setup of some of the tests. This is just an example of the activity that have been performed at the university. The other point to evaluate the quality of the welding of an hairpin is the analysis with the microscope. We can see on the first row not okay welding. There is a big void. On the other side, in the middle, there is also a not okay welding because there is no voids, but the shape of the welding joint is not okay because it is deformed. And at the end, we can see a good welding joint for the hairpin. Not only microscope, but also SEM analysis, for example, to identify voids or some particle and understand what is the particle, the material of the particle, and find out a way to remove it during the process. Also, typically stereo microscope is really important to understand if there is any, for example, change of color of the copper that identify a thermal degradation of the joint. This is not the only application of the laser welding inside our car. There is also the battery. This is just an example of the activity, of the long activity that Ferrari have with the University of Bologna to find out the correct way to weld the tab of the pouch cell of our high voltage battery. We see really an example of the analysis, visual analysis, a section analysis to identify all the parameters of the welding. And in the middle, there is an image to describe what is a pouch and how the tab of the pouch typically are welded together to close all the battery. From our experience, the laser welding, it's typically the fastest way to weld the hairpin, to weld the tab of battery, because the process is highly repeatable, and with other process, typically it's quite difficult. Also, there is no contact between the welding tool and the part to be welded. And in electric machine, this is really important because typically there is no space for the tool. And the only way is to have a technology that has any tool that got in contact. One of the targets is to reduce the thermal modification of the component that have been welded together, because when we move to the high voltage components, the clearance and the creepage distance is very, very small, and we need to keep the enamel, all the other components that are necessary for the electrical insulation without any damage. The other point is the characteristic of the welding in terms of mechanical properties, but also in terms of electrical resistance. That is one of the main topic of the welding of the tubs. For sure, the investments are really high in terms for the laser, also in this moment, and also for the automation, and this is the main drawback. Ferrari also work on other technology that is not laser, typically mechanical joint that are used in power electronics, ultrasonic, resistance welding that are typically used in all electromechanical application. That's it.
Thank you very much for this very interesting presentation. We see that Ferrari wants to keep production of critical components in-house. So the electric motor, although it is a new concept, although it brings new manufacturing techniques, it's in-house. So it underlines the fact that this is a crucial aspect of the originality of the vehicle itself. So with this small transition, I would like to see if we have any questions from the audience or online. I don't see any questions yet, but let's see. Any questions so far?
Thank you very much for your interesting talk and the insight into Ferrari. You were showing that you're using pouch cells for the build-up of the battery modules. Have you ever thought about using prismatic cells or cylindrical cells?
For sure, Ferrari is looking to all the possible cell available on the market, and for each application find out the best compromise. There is not the best cell for all the application, so each time we have to produce a new car, we receive a specification and we find out the best solution. Looking to the usage of the laser, the pouch cell is for sure okay to be laser welded. It's not the same for all the other type of cell. And this type of cell require a specific welding technology.
Thank you very much.
Maybe there are other questions, but I was actually thinking about another point. So we didn't speak so much about composite materials yet. We spoke mostly about metals, but lasers are also used for cutting composite materials, drilling, other applications. Do you see use of laser technology also from that perspective, not necessarily with the electric motor or the batteries, but also the carbon fiber components maybe?
Also for me, it's quite difficult to give you this answer because my area, competence area is related to the hybrid components. And maybe in the company there is some area of the composite where are investigating the usage of laser. But it's really difficult to me to say if yes or not.
I'm sure a lot of people are interested in that aspect. Would maybe they might also share some ideas later on, but I guess we can speak about it during the coffee break.
Yes.
Thank you very much. Okay, so once again, it's my pleasure to invite the next speaker from Lamborghini, Mr. Stefano Mazzetti, the Research and Development Manager. Once again, 4 wheels, electrification, very exciting. So thank you very much for your time.
So first of all, good morning, everybody, and thanks also for the invitation. It is a pleasure for me to be here. So my name is Stefano Mazzetti, and I try to give you some information and an overview how it is the idea of the Lamborghini for the supersport car and their future in this e-mobility context. So let's say some fact. It is clear that there is an increasing of the greenhouse gases, and this is really a problem, and it is a fact. We checked some data just for having some reference, let's say coming from Mauna Loa, that it is an observatory in Hawaii on Vulcano, and in this area that it is completely out of the industrialization and so on, but there are some data that are showing that the concentration of the CO2 is increasing in the last 70 years, and also that the temperature is increasing due to the CO2 increase of the greenhouse gases intensity. So this is a fact. And let's say the reason also, it is understandable if you see some data about the CO2 emission equivalent we put in atmosphere, and in this case the data related to fossil fuels, and you see a dramatic increasing in the last years, in particular in the last 50 years, and there is also to take in consideration that in the area related to the west side, the US, Europe, you see that more or less there is a stable situation. But in other areas like Asia or China, the situation is not stable, and the quantity of CO2 equivalent these regions are putting in the air are dramatically increasing. So it is clear that we have to do something. And there is also another point of view that we tried to understand. It is, but the greenhouse gas are coming from where? And so it is clear that there are different sources for these gases, but the energy creation is responsible of 3/4 of this emission. And if we look at the data also, we see that the road transportation, so the transportation on wheels, is responsible for the 12% of this increase of greenhouse gases. So it is clear. Also, if it is not the huge quantity or the most quantity of the emission gases, but we have to do something. Also as a little manufacturer, let's say. And if we are not convinced by us, let's say, it is clear that also the legislation is putting down the level, is reducing the level permitted in the fleet consideration in this moment. And you see that in the last 15 years, we reduced more than 50% the limits of the fleet for the CO2 emission. So it is clear that also if we like so much ICE engine, so thermodynamic engine with a lot of cylinder, a big displacement, but we have to do something. We tried also to understand what happens today in Europe. And there is a fact that if we found some data that are interesting, because we saw that more or less, if we are looking at the data coming from the quantity of CO2 or CO2 per kilometer, so let's say, in comparison with average power of the engine, of the ICE engine, we see that there is more or less the same trend in Europe in function of the power of the engine. But there is one nation, that it is Norway, that it is in incredible different situation, because they have high performance engine with a high power engine, let's say, and low emission in terms of CO2. And if we see more or less the same data in comparison with the mass of the vehicle, so the weight of the vehicle, we see more or less the same situation, that they have heavier vehicle, but less CO2 per kilometers emitted. Of course, these are tailpipe emission. And so we wanted to understand, we were looking also different information or to go deeper in this analysis. And we found that Norway, and these are data coming from 2020, so related to the 2019, and today it is, let's say, better situation. Norway has more or less 50% of new registration that it is electrified. Electrified means fully electric or hybrid. And in this case, it is clear that it seems that, not it seems, they are able to reach such kind of results because they are putting a lot of electrification in their new registration. So they are buying more car electrified. But we are looking in this moment, or at least we are seeing only the tailpipe emission. If we look at the mix of energy, electric energy in Norway, we see that electric energy in Norway is created with renewable sources and, of course, I have to say, storable sources. So they have hydropower. 96% of the quantity of electric energy in Norway was produced with hydropower. If we are looking also, if you look at the mix of wall energy, not only electric, but wall energy produced in Norway, we see that more or less the 50% doesn't emit, or it is, let's say, neutral to the CO2 in the production of the wall energy. So it seems that really the electrification gives a positive contribution to reduce the CO2 because from the beginning the electricity or the energy created with that creates electricity is, let's say, neutral to the CO2. If we look in Europe, the situation is a little bit different. First of all, we have, for what is concerning the production of electric energy, we have the 50% of the resources that can we consider neutral in terms of CO2, but the half of this 50%, it is created with nuclear power. And then we can discuss if nuclear it is fine or not for the environment. But let's say this is an open question. But the situation is completely different for Norway. And is more and more different, and unfortunately in the last period we are speaking a lot about resources for what is concerning energy due to the dramatic fact in East Europe. But you see that there is a big contribution of fossil energy in Europe for what is concerning the whole mix of energy. So at the time, it is clear that we have to do something, but it is necessary to keep in mind also how the electrification is created, or let's say how the electric energy is created, because otherwise we risk don't have the right approach in the global e-mobility. Okay, this is something that it is a consideration. So, legislation, environment consideration with, let's say, a critical approach to the resources of the electrification are anyway saying that we have to go to electrify the vehicle. But what does it mean to electrify a vehicle? Okay, we started today, we spoke a lot about battery, so we start from the core, and the core, it is the battery. Here you see a battery of 55 kilowatt hours, so energy, medium energy, let's say, it is, if I remember, it is the Zoe battery, let's say. So with this battery, you can drive for 250 on the test cycle, maybe you can drive 300 kilometers, and the energy in this package weight 325 kilo. 325 kilo with the 55 kilowatt hour are more or less equivalent to the 4-5 kilo of petrol. The same energy in both these package, or let's say boxes. And just to give some sensitivity to everybody, it means that more or less there is energy of 8.6 kilo of Nutella, the same quantity of energy. But 325 kilo. And just an historical information that the famous Fiat 500 was 475 kilo. So, let's say, if we're looking at a super sport car, and we want to run a record lap at the Nordschleife, that it is a reference for all the super sport car, we need 18 kilo of petrol, so more or less 3 times what we saw before. So you can imagine if we have to transform this in electric energy stored on the car. It means more or less that we have an increasing of weight of the car of 20%. 20% also thinking about recuperation, about efficiency, and of course all electrified devices are more efficient than the electromechanic. But anyway, the weight is becoming the challenge for the next generation of car, and also today are anyway challenge. There is also, let's say, a short overview about another topic that it is for all the cars, but I think also for the super sport car it is a topic because it is correlated to the critical way to recharge. A gas station, a petrol station, let's say, has a power installed more or less around 20 megawatt, when a fast electric rechargeable station has more or less 450 kilowatt. So the dimension of the problem for e-mobility in general, but in particular for a car that needs a lot of energy and a lot of power, you can imagine how big it is today. The weight for the super sport car, it is the real challenge. To have and to be ready for the future, it is clear that we have to rethink how we are distributing the weight, and we have to take into account that anyway the electrification gives some flexibility, or more flexibility respect to the traditional powertrain, because there is a connection of wiring in some cases. So we can put some actuators, the electric motor, we can put the battery more or less where we want or where we'd like. But also, it is necessary also to think how to manage the energy in the car. Manage means how to recharge, how to discharge, and how to keep on board the energy. And so, we think that the focus in the next period will be again on powertrain, because it was before, but will be again with different powertrains that we can imagine by wire instead of pure mechanic transmission. And the system itself, the car itself, the vehicle itself, cannot be anymore the assembly of different functions that we connect together, but has to be designed from the beginning, thinking about a function system. So more integration and more efficiency in how we are designing the cars. Everything in terms of course, for what is concerning the super sport car, because we have to deliver emotion to the driver, and so the target is to be able to keep emotion at a high level. And so we are passing from a situation where today we have energy that it is abundant. If we think 100 liters of petrol, it is light because there is a big quantity of energy, and absolutely inefficient because we know that the efficiency is very low. The next step, it is having heavy energy, the battery. We have a scarce energy because there is no big quantity of energy, and will be highly efficient. And to do that, we think that we have 3 pillars in this moment. The energy storage has to be rethink. We saw some limit. We know that we have to go beyond the limit and to find a different way. Surely we have to define different technology for the powertrain, and we need sound, because otherwise we are not able to transfer all the emotion that today we are able to give to our driver or customer. So we think, we think that we need a more collaborative approach. We need universities, we need research center, we need more than in the past open innovation, and we need inspiration for and from the new generation to understand how we can have emotion and how we can, of course, to be sustainable. To do that, Lamborghini announced last year Direzione Cortauri, so Cortauri direction, let's say it is a label of all the activities that we will do, not only on the product, but in the company. And there will be a transition that we are moving from today, where we have all the model line with only ICE engine, apart some mild hybrid, let's say, and we want to reach in the next 2 years a complete electrification. That doesn't mean starting with hybridization for the model line. But we know that in the second decades of these 10 years, we will have the first fully electrified vehicle in our model line. So we will add something that will be completely electrified. The target it is to reduce our impact in the CO2 in fleet consideration, of course, of the 50%. It is clear that today we want to pass from a neutral single approach. For instance, we have a building that it is completely neutral today, but we wanted to pass to a company that it is completely neutral. And so it means that anyway it is necessary to spend a lot of money, and we announced the 1.5 million euro of money for a transition of the company, whole company. And let's say it is clear that it is necessary an holistic approach, not only for the product, not only for the building, but for the complete activity that we are part of every day. This is the end of my presentation, and thanks a lot for them.
Thank you very much for a very comprehensive outlook on energy. I appreciate especially the fact that we need to always remember where energy comes from, because we tend to forget that there is also an environmental impact of how we get it out. I'm once again turning to the audience and reminding everybody that if there are questions online, we have a lag, so please bear with us. But we have a question in the audience.
Sure. Thank you very much. It was really very interesting. One point, everyone was aware of that, but your presentation makes this even more clear. Everything depends on the battery. So despite the amount of money a company like Lamborghini or Ferrari or Ducati is going to spend in the development of the car, of the motorbike, if there are no the proper batteries, the proper energy storage way, the efforts are limited. Your success is going to be limited by that. Is something that is seems not under your control or under the control of anybody. So we are all waiting for these new developments, despite the efforts we can put on our research. It's not a question; it's more
a consideration.
A consideration, yeah.
But, yes, you are right, let's say. So it is also consideration that we are doing every day, let's say. It is clear that my intention in the presentation is to think what does it mean e-mobility, because if e-mobility means that anyway the target is to be CO2 neutral or CO2 low impact, let's say. So sometimes it is necessary to think about the mission of what we wanted to reach. So in this moment we are in the facing a revolution that everybody is saying, okay, electrification. Electrification means that sometimes we have to take into account what happens. From my point of view, there is not only way the electrification to be neutral, because you think about e-fuel, for instance, no? E-fuel can permit to be neutral. Our costs so much, of course, but the costs are decreasing today. And with e-fuel, you can be really CO2 neutral, and you can store energy, because the big problem we have is how to store the energy. So let's say, it is very difficult. I don't have the answer. Let's say I appreciate your consideration. It is common consideration, but from my point of view, we have to try to make some effort also in large scale of direction, having a holistic approach. But there is no solution at the moment.
We have one more question from the audience.
Would hydrogen not solve your problem? Hydrogen.
Hydrogen?
Yeah.
Yeah.
Solve your problems much better than this heavy battery in the moment, still heavy?
If I went to say, sorry, it was not clear. Hydrogen?
My question is hydrogen, electric, driven car by hydrogen.
Hydrogen,
fuel cell.
let's say, it is something that, from my point of view, has sense to be investigated. There are some activities that are growing up. Let's say we are part of the group that it is strongly involved in the investigation in the hydrogen. We know that there is a big problem in the infrastructure at the moment. So the hydrogen, not itself how you are using the hydrogen, but how you can distribute the hydrogen. But for instance, hydrogen, from my point of view, it is something that has sense to be investigated. Absolutely.
Okay, thank you.
We have one other question in the audience.
Thank you very much for your interesting presentation. My question goes a little bit in the same direction as his question. We are talking mainly about lithium-ion batteries at the moment, but I'm pretty sure that you are also looking into next generation batteries, like, for example, all solid-state batteries, which was, for example, also announced by Volkswagen Group. And you said that your timeline for electrification is more or less 2025 when you want to have fully electrified vehicles. So maybe all solid-state batteries could also already be an option during that time. So could you give a statement on that?
No. If you want a direct answer, but you are right. So it is clear that the group is looking at the time, but you know that to develop a vehicle, more or less, you need 4 years if you are starting from something that it is available, let's say. So I don't think that in so short time we will be ready. Lamborghini, of course, will be ready with such kind of technology. Of course, we are strictly in contact with the group, and we are very interested to see which are the problem. The main problem is usually you are looking for an extreme density of energy. Unfortunately, we need power as Ducati, as Ferrari, and so on. So this is sometimes a trade-off that it is not so easy to have due to problem in the resistance, due to problem in the how you are design the cell, so from where you are starting. But the answer is no.
There is one other question. Very nice. The audience is participating a lot.
Thank you for the presentation. How do you, what are your requests to this, sorry, what are your requests to this laser community? How can we help you achieving some of your target? Do you have idea where we have to put focus?
If you help us, no, the request is, or let's say our needs are clear. We have to find a way to store energy, but the real challenge is how fast we are able to store and to supply energy from the storage, so from the battery, let's say. Because due to the mission of our vehicle, we could have some advantages, let's say, if we are able to charge and discharge in very fast way the battery. So we risk to have some energy to be ready to insert in the battery, but the battery cannot accept. So this is surely in what we are doing today can be a challenge for the future. Because you can imagine braking, not braking, acceleration, and so on. So at the end, of course, I'm referring to a super sport car. So the super sport car, if you drive a super sport car, you drive in the aggressive way, in particular on the lap, not on the road, let's say. So you need to upload and download energy very fast. This is the challenge at this moment. And help if you have some possibility, fine. Very good.
Yesterday we had a brainstorming session in which somebody spoke about some very interesting laser-based charging and discharging. Maybe a discussion for the coffee break later on, but thank you very much for your time. This was very interesting.
You're welcome. Thanks.
So the last presentation is from Luca Vescovi of Dallara. Yes, we have. Mr. Vescovi is the director of Dallara Research Center. Another Italian excellence, very much involved in motorsports, doing very interesting activities in electrified vehicles, very fast cars. So thank you very much for your time.
Thank you. First of all, okay, I'm Luca Vescovi. It's a pleasure to be here. I'm the research responsible for Dallara. Let's say it's a very different perspective from the colleagues. We know each other quite well. We are not the OEMs, so this morning for me was also very interesting because we always learn. Our perspective, you know, and perhaps you don't know Dallara, so we'll have a short look together. Is quite different because we are basically integrators through the years. Mr. Dallara, when I started my journey in Dallara, told me we are just doing the cold parts and we receive hot parts and we don't want to know what is inside there. Now it's a little bit different because anyway to make a good work also in the structure, also in the architecture of the car and so on, you need to know things about, let's say, the complete system. But obviously we are in a much different perspective. I try to say when they called me to present here, I told them that we are more an integrator perspective, so a real end user. So a few words on the Lara, because probably my colleagues of Ferrari, Lamborghini and Ducati don't need any presentation, but in our case it's a little bit different. We are not a so big and important company like the other ones. It's a family-owned company owned by Mr. Dallara and Mr. Pontremoli. Mr. Dallara is 86 years old, working with us on Saturday morning still now, so it's an incredible thing. Our company is more or less a 700 people company, up to 100 million or more of turnover. Very important, we are a company of engineering, because you can see that basically more than 50% is our engineering part, while the production of the car is a small amount, let's say, depending a lot on the years. So you can still see that there is a big difference with respect to my colleagues in the OEMs. We have several companies. Let's say that now they are 5. We are basically in Italy and United States. And we have an incredible history of racing cars. So the other big difference that I want to point out is that our DNA is on racing. So we started in '72 with this journey. Step by step, we increased a little bit our competencies through let's say, new markets. In 2000, we start working in automotive, so road cars. In 2020, due to COVID, also in aerospace, because to be honest, we didn't have anything to do, and we had the capacity of 600 engineers. We had this chance to work on something that was still alive. So the necessity to change, and to change very quickly. These are the 3 areas where we are active. The racing is our history. We work on several championships. In the past, I was quite, let's say, I don't want to say proud, because it's the opposite, but I had to tell that we were everywhere except Formula 1. Now we cannot, although the results are not the best in class, but we are also in F1 with Team Haas, so we are basically in all the categories. In automotive, we are basically supplying services and competencies to big OEMs, like the Pinnacle colleagues that are here today, on parts where we are, let's say, competent, so not on the complete car. In aerospace and defense, it's quite a young journey. It started, as I told you, during COVID pandemic situation, and we started learning how to design for this world and how to, let's say, give our support. And this started in some design of primary structures for helicopter and airplanes. How do we work? We work through a platform of projects, and how we try to develop our expertise. Our expertise are in lightweight design. That is my, let's say, biggest amount of job. Lightweight design through technologies, through materials. I heard some discussion regarding lightweight and regarding materials. Yeah, this is one of our main tasks. And where, for example, laser are coming and having effects. We use performance simulations, aerodynamic simulation, and hardware. We make something of electronic, especially to be, let's say, in the condition to discuss technically with the technology developer. Obviously, we are not technology developer, we are users. And then we have, let's say, everything to prototype parts. How do we work every day? We work using a sort of circle. We try to push a lot on this. We push a lot on research. We try to be at least at the leading edge designing and simulating. And we use the prototype to make a sort of real validation of our job. So the hardware parts are becoming sort of validation of our 3D models, and it's a very relevant part of our job to make validation of what we are doing. Our projects, as I told you, racing is, let's say, where we come from, where we are, where probably we will be until the racing will be alive. And during these years, we faced several architectures, several powertrains, the challenges of Formula One, always pushing at the limit of performance and weight. Formula 2, that is, for example, an entry level to prepare the drivers to Formula 1. Formula 3, that was one of the most challenging championship. We went through 3 generations of Formula E, so we approached for sure, in another perspective, not in mobility, but more in motorsport, the electrification of cars, with huge problems related to weight. So imagine it, in our job, in our world, performance and feeling of performance is the real value that we are targeting. Obviously, when the car is passing from 570 kilograms of a Formula E to 1,000 kilograms of Formula 3, sorry, to 1,000 kilograms on Formula E, it's completely different feeling, a completely different level of performance. Okay, then we have IndyCar, Super Formula, the new LMP cars, where also there hybrid solutions are coming up in the world of motorsport. Then we are, okay, small OEMs for our car. La Stradale, that is for us in reality just a sort of, I try to say test bench. We try to mount on this car everything. So we had an electric Stradale, very heavy, also in this case developed with Bosch, but very, very clever. So a car that was really very interesting in terms of driving performance and in terms of feeling sensations. Then we are just taking parts on bigger or smaller parts in consultancies for our clients. Obviously, very often these consultancies are on the competencies, the main competencies that we have. So on aerodynamics, on vehicle dynamics, on lightweighting. And then something on aerospace and defense, but really starting now. What is the key, let's say, the key perspective that I want to transfer today? As you could understand, for us was more the electrification, an occasion to develop new ideas, new platforms, new architectures. But in reality, also because we are working just very much on emotional cars. So we are not so involved in real mobility. So we are always looking for performance, for driving feeling, and let's say technical results. For example, you see here our La Stradale, but also a lot of other cars where we developed architecture for electric, for hybrid, for petrol, and every kind of propulsion, with the final scope to have, let's say, a human feeling, to improve the passion of people. This had a great effect on the motorsport. So the motorsport, due to electrification, is changing a lot. And I'm not speaking about Formula E. I'm speaking about this incredible loop that started a few years ago, where from the standard world where the human was driving real cars, several other worlds were merged together, and this gave us the possibility to, let's say, find new data, find new ideas, to make efficiency between these worlds. And speaking about the driving simulator, obviously electrification was pushing these technologies a lot. About the artificial intelligence that drives simulator, and about also artificial intelligence driving real cars. This loop, where we are very active in all of four perspectives, is creating a new kind of approach on developing car. For example, I don't know if you followed, but 9 universities were competing in Indianapolis, that is our headquarters in USA, competing with these cars that were autonomous driven. So an incredible change of mind in terms of electronics, in terms of sensors, that can have obviously a big change also in the design of the cars, of the normal cars, and also can use the data from simulators. So although we are not facing the same problems of the colleagues on the perspective of electrification and new, let's say, possibility to take out energy, our job is always to try to take the energy from the ideas of the clients and to try to use the energy in the most efficient way that we can through our competencies. And to be honest, this was a revolution of competencies. This loop of design is incredibly changing and incredibly complex. So this, I think, is the main effect on Dallara. Okay, we are very proud also to say that, as discussed by my colleagues of Ducati, Lamborghini and Ferrari, we try also to push a lot on future, because obviously all this all this change of technology, batteries, increase, efficiency increase, need to be pushed with an education. And for this reason, we are very proud to try to work on the university point of view with several activities on motorsport. For example, we have Formula SAI, where we are pushing the use of different powertrains to understand the new sensor, new technology, and so on. And I think this will be the future of Dallara, mainly staying there, keeping an eye on all the technology, and try to integrate with the maximum possible view on virtual development. I know that this, let's say, my presentation is much less relevant for the technical point of view, but this is the perspective from, let's say, an integrator. So thank you very much for your time, and it's a pleasure.
Thank you very much. I think it was a great perspective, citing things that we didn't mention, autonomous vehicles. The final race in Alabama, we remember it a bit more in detail as Politecnico, because but then there are many different things that have opened up with electrification, but artificial intelligence, we're maybe a niche working with lasers, but yes, there's a lot of work to be done. So
to be honest, also on laser, there are works. You asked about composite materials, where we are, in this case, much more skilled. There are a lot of job working. For example, we are starting using laser to concentrate nanoparticles inside the resin and to change the properties. So after creating parts, laser patterns are changing the characteristics of, let's say, areas of the product. And this is a great change for the next future. For example, creating conductive patterns in a polymer that is absolutely an insulant material. So this is an example. An example where laser is making the difference is obviously on 3D printing. We are now lasering everything in Formula One. If you see the Formula One car, 30% of the parts are now built up with 3D printed laser with metal. So there are really several areas where this technology have a secondary change. Also electrification, as I told you, the first change is huge and it's powertrain, but the second is also the mindset, the design mindset, and the possibility to use several data more and to integrate them. So a lot of things.
we have some work to do for the next years, which is very nice. I turn back to the audience to see if they have questions. We have this gentleman over there. If you can wait for the microscope, microphone.
I'm sorry.
No problem.
It's a very long day for me. Good morning. Thank you so much for your presentation. Excuse me, I wanted to just ask you, you are like a supplier of engineering work solutions for a lot of OEMs. So eventually maybe you can give us a heads up about what is the engineering engineering works that eventually the OEMs right now are requiring. For example, in this area for the
Tell me again, because I hear very, very bad, sorry.
You can take off the mask.
Yes. Well, for example, I wanted to ask you, as an engineer supplier that you are, for example, which are the main requirements that the OEMs right now are having for eventually for the nearby future, besides the the battery electrification and maybe the composite materials. Because eventually with this, we are maybe giving up a heads up about the upcoming requirements for the future, especially for the job.
Yes.
Okay, in some kind of this area.
It's clear.
Okay.
I think I have to connect with the presentation from my colleagues. So the main topic that we are facing every day, like discussed from Lamborghini, Ducati, and also Ferrari, is weight. Weight is the main problem, because when you are looking for, as I told you, a sensation, an experience of driving, so you are looking for performance, but also drivability, so sensation of driving a super sport car, the weight is making a difference. And unfortunately, the electrification made a great change in kilograms. So this is for sure the first. The second, I think, that I see every day is multifunctionalizing parts, because very often we need to shield, or we need to filter some signals, or we need to, let's say, have signals in just an area of the car. So we are hybridizing everything now. So I think the keyword for the future will be also this one, to try to reuse what we already have, perhaps rethinking about the architecture and rethinking about using the same stuff to make a lot of things. I'm on a European project working on using carbon fiber to store energy and to transmit it. So perhaps body panels in the future can be a key element also for energy storing and electric signal transmission. Today, obviously, the pressure is on weight and on cost. And to be honest, I think we are also in a period of this technology where the costs are changing every day as much as the technology. So we are really seeing a small part of the iceberg. We have to push to improve. And we have to improve on lightness, on new materials, and also on the reduction of weight on the batteries. So I think the challenge for the future is anyway to try to make this technology sustainable, also in sports car, finding architecture and let's say multi-use to reduce weight and to keep the level of feeling of the car. For example, just an example, Formula, I wanted to give you this data. I don't know if they are 100% right, but I try. Generation 2 and Generation 3 of Formula E, the car was reduced 160 kilograms. That for us is huge, starting from 1,000 kilos. So Generation 2 was 1,000. The new one will be more or less the same weight of a Formula 1, so 860, 870. It's a huge difference. So I think we have to push on this to make the best energy storing and use affordable on the vehicle.
Thank you for the presentation. Actually, you partially already answered to my question. I was wondering, you already said that the E-Formula compared to the Formula 1 or whatever, doubled the weight. So I want to know how much of the experience in E-Formula is transferable to super sport car as, I mean, is the closest sector.
Okay, I'm in Dallara since 17 years, more or less. To be very honest, when I started, a lot of things were transferred from racing to automotive. To be honest, in the last 10 years, I see vice versa, a lot. So there are two words that are quite different in terms of expectation, reliability, and so on. So it's quite complicated, I think, in these years to say how much you can gather exactly from one word to the other one. Obviously, what I see is that racing is simple. I mean, it's very difficult to win, but you are quick, you do not have so much risk, you are in a very simple environment, everything is under control. I think it's a huge occasion to test, while the level of scientific development and the level of technology in automotive is anyway on another level. So it's not a direct transfer, it's the possibility to make these words working together, that I think, to be honest, my colleagues understood 100%, because if you see all of them are making this and are trying to be complementary. I think these two worlds can compete together, so they can work in order to make a sort of debugging through racing, but then development further on licensed plates car.
Thank you very much. I think we can go on with these discussions throughout the coffee break. So let's thank our speaker. So this ends this part of the morning. I would like to thank all of our speakers. And on a personal note, for me, it was particularly exciting to have these companies that you would have their posters on the walls. And someday, you come down and speak to them. So on a personal note, I'm very happy and humbled by this experience. So let's meet at 11:10 to start again. We're a bit late with the schedule, but let's go for the coffee break. Thank you all.